we're going to explore how human engineering is pushing the absolute limits of physics out on the open ocean. We're looking at vessels so incomprehensibly massive that they honestly defy logic. They act a lot less like boats and more like giant floating cities and industrial megastructures. 4.2 million barrels. Now, I want you to picture the sheer volume of water rushing over Niagara Falls. Just imagine 4 solid minutes of that continuous, thunderous flow. Well, that staggering amount represents just one single payload of crude oil from one of these historical oceanic behemoths. It's a scale that the human brain literally struggles to compute. So the overarching question we're going to answer today is this. Just how far can human engineering stretch the limits of physics on the open ocean? I mean, how do we build structures this large without them snapping right in half, capsizing in storms, or just sinking under their own impossible weight? Let's find out by looking at the behemoths driving global commerce. Section 1. Titans of global trade. To truly understand the sheer capacity of modern shipping, consider this completely wild figure. 223 million bananas. That's exactly what the South Korean HMM Algeciras can carry in just a single trip. This ship is a mind-bending 1,312 feet long. To put that into perspective, that's 4 football fields laid end to end. It holds almost 24,000 standard shipping containers stacked up to 109 feet high in the air. So whether it's 8.35 million microwaves or literally hundreds of millions of bananas, this is the kind of vessel physically moving the world's goods every single day. Now, when we look at bulk carriers moving raw earth, the MS or Brazil is an absolute monster. It's almost 1,200 feet long, with 7 holds, and each one of those holds is the size of a tennis court. It carries the equivalent of 11,150 trucks worth of heavy iron ore. Now, because of this immense weight, it plods along at just 15.4 knots. But hey, don't let that slow speed fool you. As we saw back in 2008 with the slightly smaller Shinyo Sawako, pure mass makes these ships incredibly dangerous. The Sawako collided with a smaller vessel, and despite the really low speeds, the smaller boat was completely destroyed simply by the unstoppable momentum of the Sawako's mighty hull. Size, quite literally, crushes everything in its path. Section 2. Engineering marvels, solving giant problems. Okay, so the absolutely crucial point here is how you actually lift something massive out at sea without flipping right over. Enter the pioneering spirit. This vessel lifted a 24,000-ton oil platform topside. That is more than 6 times the weight of the Eiffel Tower. So how on earth did they do it? Well, it's all thanks to a brilliant semi-submersible secret. First, the ship intentionally sinks itself up to 88 feet below the waterline. Then it slips its massive twin holes right underneath the oil rig. And finally, it empties its ballast tanks, rising up and lifting the cargo squarely in its center of gravity. This ingenious design allows it to safely lift these monstrous structures, even while getting battered by 11-foot ocean waves. Now check this out. Why does the Ramform Titan look like a sliced triangle? Its back end, or stern, is an unbelievably 229 feet wide. It's actually often called the ugliest ship in the world, but as you might guess, there is a highly specific, fascinating engineering reason for all that junk in the trunk. So here's the secret mechanism behind its unique, kind of ugly shape. It's the world's widest single-hull ship because it desperately needs extreme stability to drag 24 massive streamer cables behind it. And get this, each of these cables is lined with seismic sensors and is over 39,000 feet long. By spreading out so widely, the ship ensures these literal miles of cables don't tangle as they map a 4.5 square mile grid of the seabed in incredible 3D, hunting for hidden oil and gas deep below the ocean floor. Section 3. Drama on the high seas. The Seawise Giant had a genuinely cinematic 40-year timeline. This ship was a jaw-dropping 1,503 feet long. If you stood it on end, no joke, it would be taller than the Empire State Building. It carried so much oil it sat 80 feet below the waterline, which actually made it too deep to even use the Panama Canal. But what's wildest is its history. It was literally bombed and sunk in the shallow waters off the Iranian coast during the Iran-Iraq War in 1988. But it was just too massive and too precious to leave rotting there. So it was miraculously salvaged from the ocean floor, rebuilt, renamed the Happy Giant, and sailed for another 2 decades before finally being scrapped in 2009. And then we have the Lafayette. This is a story of pure illicit piracy on a massive industrial scale. Originally a Russian oil tanker,
A cool $100 million was spent converting it into the world's largest floating fish factory. It was equipped with a giant hose to literally suck up fish from smaller boats and freeze up to 1,500 tons a day. But they used this monstrous capability to illegally plunder the South American seas. Peru slapped them with an $800,000 fine. The ship's owners sneakily renamed her the Damanzai to try and hide from the law, but a vessel this massive really couldn't hide forever. Federal agents finally boarded and detained the floating factory in 2018.
Section 4. Floating passenger cities. Now, before we look at these massive passenger ships, we really need to clarify the term gross tonnage. When we talk about cruise ships, gross tonnage doesn't actually mean physical weight in pounds or kilograms. It's a nautical measurement of a ship's overall internal volume. Essentially, it measures just how much cavernous empty space is inside for rooms, restaurants, and theaters. The iconic Queen Mary II was a giant of its time, 1,132 feet long, costing an inflation-adjusted $1 billion. To give you an idea of her size, her propellers alone are wider than a London double-decker bus. Yet despite all that, she is entirely dwarfed by the Symphony of the Seas. The Symphony is essentially a sideways skyscraper. It has an internal volume of 230,000 gross tonnage, allowing it to carry 5,600 guests across 18 decks that feature 22 restaurants, ice rinks, and even the tallest slide at sea. The cost for all this? A colossal $1.35 billion to build. Section 5. Colossal naval power. Launched way back in 1961, the USS Enterprise remains the longest Navy vessel ever built at 1,123 feet. It featured an incredible 4.5 acres of flight deck. But what made it truly terrifying was its power source. 8 separate nuclear reactors propelling this floating fortress to almost 38 miles per hour. The financial investment, however, was just mind-boggling. In today's money, it cost an inflation-adjusted $3.9 billion. It was so astronomically expensive that the Navy had to completely cancel its planned 6 sister ships. So, take a look at the USS Zumwalt. Why is the largest naval destroyer in the world shaped like a sleek, floating pyramid instead of having the traditional rounded hull we're all used to seeing? The answer comes down to the crazy physics of modern stealth. Traditional rounded ships are giant radar reflectors, but the Zumwalt's incredibly sharp geometric angles are designed specifically to bounce radio energy completely away from enemy radar systems. Despite being 610 feet long, which is 40% larger than current destroyers, this specific geometry makes it 50 times harder to spot. But, as you can probably guess, pushing the limits of physics isn't cheap. The complex technology caused the budget to balloon to an outrageous $7.5 billion per ship. Because of this massive price tag, the U.S. Navy only ever built 3 of them. Section 6. The ultimate behemoth. The Prelude FLNG. Okay, so FLNG stands for Floating Liquefied Natural Gas Platform. This means the Prelude isn't just a transport vessel that moves goods from port A to port B. No, it is an entire, fully functioning offshore industrial plant that extracts, processes, and stores natural gas right out in the middle of the ocean. The Prelude is over 1,600 feet long. That is longer than 4 soccer fields. It was actually constructed using more steel than the entire World Trade Center complex. Fully loaded, it weighs about the same as 6 of the largest aircraft carriers combined. And to keep it securely in place while it dredges up 3.6 million tons of liquid gas a year, it is anchored to the seafloor using massive mooring chains made up of 25,000 colossal links. But here is the ultimate irony of the Prelude. Despite having 3 incredibly powerful 6,700 horsepower thrusters to position itself against the wind, this floating city has absolutely no propulsion engines of its own. Yep, technically speaking, the largest floating structure ever built by humans is just a barge. To get to its home 330 miles off the Australian coast, it had to be slowly dragged across the ocean by a massive fleet of 250-foot tugboats. Once there, it just attaches to a central turret and swivels around like a giant weather vane in the wind. From vessels that lift entire oil rigs in storm swells, to sunken giants reborn, to stealth pyramids and floating industrial cities without engines, we've really seen how human ingenuity bends the rules of physics. As our engineering ambitions clearly begin to outgrow the very oceans they float on, what impossible megastructure will humanity dream up and build next?